being 1 second. Physics relies on this being 1 second, right? When you when you have your clock longitude like that, that's why you need two of them. Like say this blue line and this red line. Here's a whole line of it, right? But if you turned your clock and you did it longitudinal and you did 2 seconds, two-way though, right? Two-way. See, the red thing would go off of this black plate, bottom plate. So when it bounces off, it has to go all the way up to where this red plate is. Because the black plate that used to be here, that dotted line, is now moved up to here, right? But on the way back, right, this would be the bottom plate of this, right? This red dotted line. This red dotted line moves up and catches it when it comes back on the second thing. So this red line and this black line would be like this, right? And this blue line and red line would be like this blue line and red line. See how they are equal? Planck's second isn't one of them. It's a two-way thing. And that's what, see, the synapses, they must have to have two-way communication to think. The rotation or acceleration, throwing photons from atom to atom, they must need a two-way communication, okay? And that's why the Planck second is two-way communication, two-way travel, okay? So the only thing that we have to worry about, right, is this black man, okay? Why is he, he ain't going to think we see why he thinks it, he thinks it, he thinks it. But the black man, well, it don't make sense on him, right? But this is the thing. Now that this is a Planck second, right, that means all physics, atom to atom, they need two-way communication, okay? Otherwise, a Planck second hasn't happened, okay? So, you know what I mean? When this guy sends photons to him, okay, and it comes back, the photons go into there, that don't count, that don't matter, okay? And I'll show you what's going on in his brain after I get to the next whiteboard, okay? But this is the whole thing, though, right? Because I say that when this guy's going to another star system. So this is his clock. He starts accelerating. His line gets bigger and bigger, right? And there's your gamma, vertical, hypotenuse over vertical line. But then you start going constant velocity, right? You don't have rockets on the whole time. Now you have your stretched out second. That's your time. You don't time dilate anymore, but you get that. You keep that second. This looks like it takes 2 seconds to do that. You know what I mean? So you cut down time by half. This is the time. This represents the time that physics. This represents your Planck second. Okay. Right. Then when you start deaccelerating, you make this line smaller and smaller until it goes back to its original form. That's why I thought this was a Planck second. That's not a Planck second. You need both up and down as a Planck second. And that's why I was saying, from here to here, no physics can take place. Because you can't, if your synapses throw photons at each other, right? Then when this one throws photons to here, when you're standing still, that's a second, or that's a Planck second, say. When you do it from here to here, now you've made the Planck second bigger. You made physics take longer to take long. If it takes this much longer to think, it takes that much longer for electronics. It takes that much longer for everything, acceleration, everything you can think of, okay? All physics relies on this. But the thing is, that isn't a Planck second. You got to go two. This is a Planck second. And the reason why these are, like that was a Planck second before, I thought, right? Because that you can't have nothing in between. You can't have any acceleration. You can't have any thoughts. You can't have any electronics. Nothing can happen in between here and here, right? Because this is you're transferring information from one atom to the other, one synapse to the other, one whatever to the other, right? So in between there, nothing's happening. No physics is taking place in the whole universe during this time. Because all they're doing is atoms is just transferring information from synapses to synapses, and atoms and clock hands, and that kind of thing for acceleration and etc., right? thing is, that's not a Planck second. Right? And that's why you couldn't see it. No physics takes place unless you have a back and forth communication. There's no other way. It has to be that way, okay? And, okay, so I'm saying this up and down clock standing still. If you had a horizontal clock standing still, you know, this will add up to a second, right? They'll add up. The two-way thing, right, because it's going to jump, it's going to take a long time to get to the first plate, but then to bounce back, because you're going this way, right, it's only going to take a second. That's what that little thing is. That's the going down tick, right? These two lines are exactly the same length, no doubt, okay? Or, okay, if this does not fully explain everything, then the photon clock will have a longer line, the horizontal type, this type, will have a longer line, okay, that corresponds with the length contraction mathematically. Mathematically, either these are both the same exact length, right, whether your photon clock is like that or like that, right, or if time dilation, this thing here does not explain everything, right, all right, then that means one thing and one thing only. This line right here is slightly longer, and that's what accounts for length contraction. But if you can just, I think you can just use this. Why can't you just say this? I bet these two lines are exactly the same. But either way, this is a Planck second, okay? And that determines the speed of physics, okay? So in between the up and down, or the up and down here, there is no physics happening anywhere in the universe, okay? All there is photons traveling to the other plate, the other synapse, the other atom, to do physics, okay? During that Planck second, nothing's happening except photons traveling, man. You know what I'm saying? All right? That's why you can't see into the Planck second, okay? Because the Planck second involves two-way communication, okay? And we're going to get into the black man here as soon as I get on to the next whiteboard, okay? On why, how is he seeing things all screwed up? Because so far, everything sounds logical, right? The green man sounds logical. The red and the blue man sound logical, because that's true. It's going to take 1.5 C to get here, but it's going to take half C to get back. So it's going to come out to be 1 C, both, you know, both way directions. Same way with the red man. He's not going to know anything different. And the compression is opposite. It'll just compress and come back on its way back. This one, it'll uncompress on its way back. So the blue man and the red man will not be any wiser to this. As a matter of fact, if this wasn't true, they wouldn't see what they see. This explains why they see what they see, okay? Because they need two-way communication, okay? But the black man, he's the one that's left. Let me see what else is on my whiteboard before I race it off and get on to him, okay? But yeah, here's the thing. This is when they're I think this is what it is, okay? This would be the longitudinal clock, and this would be the vertical clock, right? I think they add up evenly. If they don't fully explain, if that doesn't fully explain time dilation in every instance, it's because we're not taking it. This longitudinal clock is actually slightly longer than the vertical clock, and that is where the length contraction is, you know, coming from. To answer about the black man, it's because you need two-way light is the Planck second, and I'm going to get on to him. Here comes a lot of guesses and assumptions, but remember, we have to keep this green C relative to this space-time, right? And you can see how their perception would believe that it was C, right? Because it would go 1.5 C that way and half C back, and that would be like C. Same here. So the only one we have left is the black guy, right? That's why I said this is. But you think about if it's two-way communication, right? Like down here, this isn't a Planck second, it's two-way, right? No physics can happen in between those two, that Planck second, right? Think of these as, you know, this atom talking to that atom. He's going to throw this thing out, it's going to come back as it was originally. Think of this black man as a photon collector, right? There's the atoms in the photon collector, the first two layers. Right? Like if this was a photon collector, if you threw out some photons, and the photons was bouncing back. Yeah, if it was bouncing back, it would be 1.5 C and half C. This photon collector, right, it's an electronic part. It's going to go to that first atom, right, and then it's going to keep continuing to next atom till it goes into the electronics, right? But I bet you $1 million it goes back and forth so that it sees what they, you know what I mean? And this becomes the Planck second. Like I said, I'm guessing here. You're going to have this longitudinal thing, right? I don't know how it works, really, I don't. But I do know that this is better theory than what they have, okay? That this two-way light is the same as this two-way light. That's a Planck second, okay? Maybe the brain, when you get from the blue man, you know what I mean? It goes into this synapses and it gets shot this way, knowing that you're moving or whatever. Somehow he knows you're moving or whatever. Or the red man comes and it goes to the blue whatever. Now, when it goes back that way to give the information, it's going to be, decompressed or compressed. Decompressed or compressed, going the opposite direction, right, on the synapses. And the speed is going to be diminished. So it kind of works out. If that's the way it happens, you know what I mean, then this all is true. You know what I mean? Because it would just send it to the opposite direction that you're going. You know what I mean? And then it would everything would cancel out, right? Because what happened in between this Planck seconds doesn't matter. It doesn't exist really, you know what I mean? Because we can't perceive a Planck second. So do I know this is happening? No, I do not know this is happening. God, no. But I do know the green man is doing that. I know that relative to this frame, light is moving at half C here and 1.5 C here. These are facts, okay? Not because Einstein said it, because the formula, we just seen it. Light has to move at C relative to this, not to this frame, okay? So we have to go from there and make everything make sense to this, right? They're not doing that, okay? They're just making magic and, we got the whole entire universe contracts for... My thing is crazy. They're saying the entire universe contracts, and we're all living in all different universes because it contracts different from you than them, and we all have... That's magic. At least mine makes somewhat kind of sense. It has to be this way. The Planck second has to be... There's no other way, okay, I've been thinking about this longitudinal clock thing for weeks. There's no other way to explain this. There's no way to have a little... if this was a Planck second and this is a Planck second, you can't have both of them be Planck seconds. This one's tiny and this one's giant, okay? There's no other way to explain... You can't explain that away. And then it hit me. Oh, you can explain it away, because this, from here to here, when I thought that was a Planck second, that means no physics is happening. This Planck second isn't happening on, photons are created, different times or whatever, so it's different for each person or whatever you're talking about. But pretend that this Planck second happened during all physics at the same exact time, all the time, okay? That means during that time, the entire universe would be frozen, okay? Nothing would be happening except for photons, or I keep calling them photons, information carriers, going from one plate to the other. That's the only thing that would happen, okay? This is why we can't see this length or this time span.